be that x is greater than or equal to 0, or if you want to write it in interval notation, we're going from 0 to infinity. Either one of those is perfectly fine. All right, and lastly, g of g. So g of x, that is g of the square root of 2 minus x, which is really the square root of 2 minus the square root of 2 minus x. Now, I can't simplify anything here because that is 2 minus on the inside. If that had been multiplication, we could have done something, but we're kind of stuck. This is as nice as it's going to get, unfortunately. So now we have to talk about domain. So first of all, here, when we have the square root of 2 minus x, I want to make sure that x is going to be less than or equal to 2 to make sure that radical we can take. We also are going to have an issue, though, because we want to make sure that here is going to be the square root of 2 minus x has to be less than or equal to 2. That way I can take that second radical on the outside. So when I square both, that's going to give me negative 4 and 4. Whoops, 4, 2 minus x. And then if I were to subtract 2, that's going to give us negative 6 is less than or equal to negative x is less than or equal to 2. And then when we multiply, this is actually going to turn into an OR problem. We get 6 greater than or equal to x greater than or equal to negative 2. So it's kind of a little bit flipped around here. But we want to make sure that whatever we're plugging in is going to be between negative 2 and 6. So I can actually rewrite this. Negative 2 is less than or equal to x is less than or equal to 6. And we can double check. If I were to plug in negative 2 there, that would give me 4 minus minus 2, which is, or sorry, 2 minus minus 2. So that's the square root of 4, which would work. If I plugged in 6, that would be the square root of, well, negative 4. So that wouldn't work. So we want to make sure we're including both kind of restrictions here. So if x has to be less than or equal to 2 and it has to follow this, what really happens is that we need to be between negative 2 and that positive 2. We want to kind of do whatever's the most restrictive between both of those pieces of information. So you could also write it from negative 2 to 2. Either way, it means the exact same thing. It's up to you. All right, example 5. This gets a little bit trickier. We want f of g of h. So we're actually going to do this 3 times. F of g of h of x. Same concept, though. We're just going to work from the inside out. So we have f of g of, and whatever h of x is. So h of x is x plus 3. And then we're going to take that x plus 3 and put it in place of the x here. So that's going to give us f of x plus 3 to the 10th power. Yikes. And then we're going to take that and put it in place of the x's here. So that's going to give us a fraction. That first x becomes x plus 3 to the 10th. And then that second fraction or the bottom becomes x plus 3 to the 10th plus 1. Okay. Luckily, we do not have to find the domain here. However, if we did have to, we would be considering the fact that we do have a denominator here. So we'd want to make sure we weren't worried about having, x or our denominator being 0. All right. In example 6, they're saying that basically I'm giving you the answer and you have to work backwards and find the functions you began with. So capital F of x is equal to the 4th root of the the 4th root of x plus 9. We want to find those beginning functions such that f is equal to f of g of x. So there could maybe be more than one answer here, but we have f of g of x. That's really what this is equal to the 4th root of x plus 9. Now there are a few ways we could do this problem. There's not one correct answer here. We just want to make sure that we can kind of work this out. So I see that 4th root function, and maybe I would say that is the most outside operation going on here. So maybe let's say that f of x could have been the 4th root of x, right? If that's the case, when I put g of x in, I have to replace x with x plus 9. So maybe g of x was equal to x plus 9. Now this isn't the only way we could do this, but what would happen is I would take x plus 9 and put it inside the radical, and that would work out. We could also kind of take the lazy way out and say something that like g of x was equal to just x. And then f of x was equal to the function that's already there. There could be a few ways to go about doing this sort of